Peace everyone and welcome to the channel. The reason I started this channel is simple. I want to follow truth wherever it leads, even when the conclusions are uncomfortable. But before we can determine whether something is true, you first have to understand how human beings recognize truth in the first place. What standards distinguish truth from error? Why do intelligent, sincere people examining the same reality so often reach completely different conclusions? Those questions led me to develop what I call the calibration problem, a framework for understanding how human reasoning actually works and why disagreement is such a persistent feature of our world. This presentation begins part one of the series entitled How Assumed Conclusions Prevent Truth-Tracking Reasoning. Throughout this series, we'll gradually build a model for evaluating competing explanations, not by asking which one we happen to prefer, but by asking which one best satisfies the shared constraints imposed by reality itself. This presentation accompanies my three-part essay series published on Substack. If you'd like to explore the complete written argument, you'll find a link in the description below. With that, let's begin. Have you ever wondered why two intelligent, sincere people can examine exactly the same reality and yet reach completely opposite conclusions? For a long time, I assumed the process of discovering truth was fairly straightforward. We begin by forming a hypothesis. We gather observations from the world around us. We interpret those observations using the rules, assumptions, and principles we have accumulated throughout our lives. And eventually, we arrive at a conclusion. On the surface, that seems perfectly reasonable. If everyone has access to the same reality, shouldn't careful reasoning eventually lead us to the same destination? But that question always bothered me. If this is really how human reasoning works, why do disagreement, division, and competing worldviews seem to be the norm rather than the exception? If we are all observing the same world, why do we keep arriving at different truths? That simple question became the starting point of a much deeper investigation. The question stayed with me for years. If we are all living in the same reality, why do intelligent people keep reaching fundamentally different conclusions about what is true? At first, I assumed the explanation must be fairly simple. Perhaps some people just didn't have enough information. Perhaps they had made a mistake in their reasoning. Or perhaps they simply weren't thinking carefully enough. But the more I examined competing worldviews, the less convincing those explanations became. I found brilliant, sincere, highly educated people studying the very same reality and yet arriving at conclusions that were not merely different, but fundamentally incompatible. That realization eventually led me to write Reason, Revelation, and the Architecture of Truth, a framework for evaluating worldviews. After years of wrestling with this problem, one insight emerged that was surprisingly simple. People argue at the level of conclusions, while their real disagreement exists at the level of foundations. Up to this point, we have focused on the conclusions people reach. But the more I reflected on the problem, the more I realized something important. Disagreement doesn't actually begin when two people sit down to debate. By the time the discussion starts, the foundations have already been laid. Long before we defend a conclusion, we have already adopted a set of assumptions about the world. Our rules and axioms, our lived experiences, our values, and the interpretive lenses through which we understand reality. Those foundations quietly shape how we interpret the very same observations, often without us even realizing it. In other words, People aren't simply arguing over conclusions. They're reasoning from different foundations. That naturally raises another question. If disagreement begins at the level of foundations, how do we determine which foundations are actually reliable? That question led me to search for a shared set of objective criteria, standards that could evaluate any worldview at the level of its first principles, rather than merely comparing the conclusions. Eventually, that search converged on three fundamental tests that every worldview must satisfy if it is to serve as a reliable guide to truth. Those three tests form the framework we'll examine next. At this point, I started looking at the problem differently. Rather than thinking about individual arguments in isolation, I began thinking in terms of systems. Imagine trying to assemble a large jigsaw puzzle without ever seeing the picture on the box. A single puzzle piece tells you almost nothing. By itself, it has no obvious meaning. It only begins to make sense when it connects to the pieces around it. Without the picture on the box to guide you, building the puzzle becomes slow, uncertain, and full of false starts. I think our search for truth operates under a remarkably similar constraint. We are all trying to build a model of reality without ever seeing the completed picture. Ever more challenging, we have to discover the pieces ourselves through observation, reasoning, and judgment. We don't begin with certainty, we build it piece by piece. And the only way we can know whether our model is moving in the right direction is when those pieces begin to fit together into a coherent whole. That brings us to the first criterion in the framework: coherence. Coherence simply means that a model must remain internally consistent. Its conclusions cannot contradict its own rules. Every part of the system has to fit together as a unified whole. When I apply this to a text, it means the interpretation must remain consistent at every level. The textual analysis, the grammatical analysis, and the semantic analysis should all point toward the same conclusion. If we constantly have to invent exceptions or rescue explanations every time the model encounters a difficulty, that's usually a sign that something has gone wrong. This type of reasoning relies primarily on deduction. We begin with a general rule, apply it to a specific case, and ask a simple question. Does the conclusion follow logically from the premises? If it does, the model is coherent. If it doesn't, the internal structure begins to collapse. But coherence by itself isn't enough. A model can be perfectly logical and still have nothing to do with reality. That's where the second criterion comes in. But internal consistency by itself doesn't tell us whether a model is true. A model can be perfectly coherent and still describe a world that doesn't actually exist. Take J.K. Rowling's Harry Potter. It is an extraordinarily coherent fictional universe. Its history, its characters, its rules, and even its magic all fit together remarkably well. Within its own world, almost everything makes sense. Yet none of us conclude that Hogwarts is a real place simply because the story is internally consistent. That brings us to the second criterion: correspondence. A worldview must do more than hold together logically. It must also correspond with the world we actually observe. This is where inductive reasoning comes into play. Rather than beginning with the general rule, induction begins with observation. We examine patterns in the world around us and ask whether reality actually supports the model we are proposing. In other words, coherence asks, Does the model make sense? Correspondence asks, does reality agree with the model? But even those two questions together still aren't enough. There is one more problem we have to solve. At this point, we have two criteria. A worldview should be coherent. It should also correspond with what we observe. But even together, these two tests still don't guarantee that we have arrived at the truth. Imagine a child born and raised entirely inside the wizarding world of Harry Potter at Universal Studios. From the day he was born, he is taught that Hogwarts is real. The seven books are treated as history. Wands perform magic. Wizards are ordinary people. Everything around him reinforces that picture. His world is internally coherent. His everyday experience continually corresponds with what we see. From inside that world, he has no reason to doubt it. But there is one thing he does not possess. He has no reference point outside the system. He lacks a vantage point from which he can recognize that what appears to be an entire universe is actually a carefully manufactured environment contained within a much larger reality. That is why coherence and correspondence are not enough. We need a third axis, one that allows us to step back, compare competing explanations, and ask which one best accounts for the totality of the evidence. I call this third axis calibration. Calibration provides the external criterion by which competing models can be evaluated. Together, coherence, correspondence, and calibration form what I call the CCC Framework. Let's look a little more closely at calibration. Calibration is a governing standard that is itself grounded in reality. Every human being is required to exercise judgment. We cannot avoid it. Every decision we make requires us to choose between competing explanations of the world. Even a nihilist or a radical skeptic cannot escape this axis, because claiming that nothing has meaning is still a judgment about reality. Calibration is the bridge between the observer and the world being observed. It connects our internal perspective with the external architecture of reality. Within the CCC framework, calibration corresponds to abductive reasoning, the reasoning we use to generate hypotheses and select the explanation that best fits the evidence while requiring the fewest assumptions. But here's the important point. None of the three reasoning modes is sufficient on its own. Deduction gives us logical consistency, but by itself it cannot generate new knowledge. It simply unfolds the implications of what we already assume. Induction gives us observations, but observations alone are just disconnected data until they are organized into an explanatory model. And abduction, without the discipline provided by coherence and correspondence, quickly degenerates into speculation. Intelligence emerges only when all three operate together. That is why I think of this framework as a three-legged stool. Remove any one leg and the stool collapses. Remove coherence and our reasoning becomes internally contradictory. Remove correspondence and we lose contact with reality. Remove calibration and we lose any principled way of deciding which explanation is actually better. Only when coherence, correspondence, and calibration work together do we have a system capable of reliably tracking truth. Let's step back and bring everything together. The CCC framework reflects the way human reasoning actually works. It isn't built around a single mode of reasoning, but around three that work together as an integrated system. Coherence corresponds to deduction. It asks whether our conclusions follow logically from our starting assumptions without introducing contradictions. Correspondence corresponds to induction. It asks whether those conclusions remain consistent with observation and lived experience. And calibration corresponds to abduction. It allows us to compare competing explanations and determine which one provides the best overall fit with the totality of the evidence while requiring the fewest assumptions. These are not three independent tests. They are three complementary dimensions of a single truth tracking framework. When they operate together, they provide a systematic way of evaluating competing worldviews rather than simply defending the one we already hold. But our work is not finished. We have identified the need for calibration. We have shown why it cannot be ignored. The obvious question now becomes, what determines whether one calibration is better than another? Or stated another way, what criterion justifies what we accept as knowledge and brings us closer to the truth? That question takes us to the next and final section of part 1. This brings us to what I believe is one of the most profound questions in philosophy. Can human beings actually ground truth on their own? Or is there fundamental constraint built into reality itself? My search for an answer led me to a remarkable realization. For nearly 2,000 years, philosophers have wrestled with this very question. Despite their many differences, they repeatedly encountered the same obstacle. Every attempt to justify knowledge from within human reason eventually arrives at one of three dead ends. The first is circular justification, where the conclusion simply feeds back into the premise. The second is infinite regress, where every justification requires another justification with no end in sight. And the third is the dogmatic stop, where you simply declare something to be self-evident because ultimately it just is. These three dead ends are known collectively as Agrippa's trilemma, sometimes called the Munchausen trilemma, preserved in the Pyrrhonian skeptical tradition. But here's the crucial insight. This isn't merely an abstract philosophical puzzle. It reveals something structural about the architecture of reality itself. Neither you nor I can absolutely prove ultimate claims, whether God exists, what preceded the Big Bang, or why the laws of nature are what they are, from within human reason alone. The same limitation ultimately reaches every knowledge system. It touches philosophy. It touches mathematics through Gödel's incompleteness theorem. It even reaches physics, where our explanations of things like gravity eventually terminate in assumptions that themselves cannot be proven from within the system. No worldview is immune. The lesson is one of epistemic humility. Human knowledge cannot fully ground truth from within a closed human system. Uncertainty is not a temporary inconvenience. It is built into the architecture of reality. And once we recognize that, our goal changes. The rational objective is no longer absolute certainty. It is closeness to truth. If absolute certainty is beyond the reach of human reason, then the obvious question is, how do we move closer to the truth? The answer is surprisingly simple. Rather than asking whether a single worldview can absolutely prove itself, we compare competing explanations against a common external standard. In other words, we introduce an external calibration point, a standard grounded not in any one worldview, but in the shared constraints imposed by reality itself. Instead of asking, can this worldview prove everything? We ask a much better question. Which explanation best satisfies the shared constraints of reality? That brings us directly back to the CCC framework. We compare competing worldviews side by side. We examine whether they remain internally coherent, whether they correspond with observation and lived experience, and whether, through calibration, they provide the best explanation with the fewest assumptions. Notice what has changed. We are no longer searching for an impossible self-grounding proof. We are performing comparative evaluation. The goal is to determine which explanation provides the strongest overall account of reality. That is the central insight behind the framework. The CCC framework is not about absolute justification. It is about comparative superiority under shared evaluative constraints. The trilemma carries an important implication. Disagreement is inevitable because every worldview begins from unprovable first principles. The solution, however, is not dogmatism, relativism, or radical skepticism. It is comparative evaluation, evaluating competing worldviews under the same shared constraints to determine which one most consistently satisfies coherence, correspondence, and calibration. The better explanation is the one that best accounts for reality with the fewest assumptions. This brings us to the central conclusion of Part 1. Humans cannot ground truth. The best we can do is use comparative evaluation as a proxy for truth tracking. But our journey isn't finished. Most people readily agree that explanations should be coherent and correspond with reality. The deepest disagreements arise somewhere else, along the calibration axis. It is there that worldviews diverge, priorities are established, and conclusions are ultimately shaped. In Part 2, we'll reverse the causal chain and examine the role calibration plays in shaping our reasoning. We'll see why short-term optimization can distort our understanding of reality and how miscalibration can produce consequences that remain hidden until much later. Humans cannot ground truth, but we can become better truth trackers. Thank you for watching, and I'll see you in Part 2.